Higher Math, Straight Line, Exercise 13C, Question 10. So I had a few requests for this, so we'll go over parts 10A, 10B, and 10C. This question is very, very similar to a question that was at the end of a Higher Maths Paper 1, probably about 7 or 8 years ago, I think. But basically it's semi-tricky because it's at the end of Paper 1, and I will go over it. So part of the line L1 with equation 2y equals x plus 6 as shown in the diagram. The line L2 is parallel to L1, so L2 will have the same gradient as L1 and passes through the point 0, -2. Show that the equation of L2 is 2y equals x minus 4 and hence write down the coordinates of A. Well, first of all, as the line L2 is parallel to L1, it will have the same gradient, so rearrange the equation of line L1 into the form y equals mx plus c, and we can see the gradient of that line will be 1/2. And then we know the line L2 passes through the point 0, -2. So we could just use y equals mx plus c and write y equals 1/2 x minus 2. Or we could substitute into y minus b equals m bracket x minus a. So substituting in, we have y plus 2 equals 1/2 x. Double both sides of the equation. So 2 bracket y plus 2 equals x. Expand, and if we arrange that into the form that they asked for, where 2y is the subject, subtracting 4 from both sides here, 2y equals x minus 4. And part A also says, and hence write down the coordinates of A. Well, A is on the x-axis. Any point on the x-axis will have a y-coordinate of 0, so we can substitute in 0 for y, because this equation links together the x and the y coordinates anywhere on the straight line. So if the y coordinate's 0, so 2 zeros are 0, then 0 will equal x minus 4, or x minus 4 equals 0. So x will equal 4. So we know the y coordinate's 0, the x coordinate's 4, so A lies at 4, 0. Question B. Given that the line AB is perpendicular to both lines, find algebraically the coordinates of B. Well, we know the gradient of L1 and L2 is 1/2. So perpendicular to that, well, remember we'll flip it upside down, change the sign. So the gradient of the line AB will be -2. We know it's going through point A, which is at 4, 0. So y minus b equals m bracket x minus a. Substituting in, we will have y equals -2x plus 8. And find algebraically the coordinates of B. So that's the equation of the line AB, and we want to find out where that meets the line 2y equals x plus 6, and that will give us the coordinates of B. So simultaneous equations to find where two lines meet. So again, guys, label your equations 1 and 2. What I've done here, I've collected all the letter terms to the left-hand side because that's what you're used to from National 5. You don't need to do that, but just to make it as easy as possible to follow in this video, I have done that. And I'm going to double equation 1 to make the coefficients of y equal. So I've said that I'm doubling equation 1, I've labelled that equation 3. And then I'm saying I'm doing equation 3 subtract equation 2. So 16 minus 6, 4x subtract minus x is 5x. 2y minus 2y is 0, which is why there's no y terms there. So x will be 2. And substitute that back into equation 1 to find the y coordinates, which will be 4. So the point B lies at 2, 4. Calculate the exact shortest distance between the lines L1 and L2. So the shortest distance given by the length of AB is AB is perpendicular to L1 and L2. Okay, so the shortest distance between two lines will be a line that is at a right angle to both of those lines. So I know where A is, I know where B is, so to get from A to B, I'm essentially going 2 to the left and 4 up. So a little bit of Pythagoras, 2 squared plus 4 squared is 20, square rooted is root 20.